Imagine waking up to a universe where Jupiter, the colossal gas giant, has vanished. In its place, a black hole. How would this cosmic swap affect our solar system? Would Earth be in danger? Let's embark on this interstellar journey to uncover the truth. Jupiter isn't just another planet in our solar system, it's the behemoth that holds the planetary lineup together. But what if, overnight, Jupiter was replaced by a black hole of equivalent mass? Would the solar system remain harmonious, or would chaos ensue? Before diving into this scenario, let's grasp the basics of black holes. These enigmatic entities are regions in space where gravity is so intense that nothing, not even light, can escape. They typically form when massive stars exhaust their nuclear fuel and collapse under their own gravity. Black holes come in various sizes. Stellar mass black holes, ranging from a few to tens of solar masses. Supermassive black holes found at galaxy centers, containing millions to billions of solar masses. Intermediate and primordial black holes. Hypothetical classes with masses between stellar and supermassive and tiny black holes formed soon after the Big Bang, respectively. Jupiter isn't just the largest planet, it's a gravitational anchor. With a mass approximately 0.095 times that of the Sun, it significantly influences the orbits of other celestial bodies. Its gravitational pull has been instrumental in shaping the asteroid belt, capturing and redirecting comets and asteroids, often termed as the solar system's vacuum cleaner, maintaining the stability of the inner planet's orbits, including Earth's. Let's hypothesize. Jupiter is instantaneously replaced by a black hole of the same mass. How does this affect the solar system? Gravity depends on mass and distance. A black hole with Jupiter's mass would exert the same gravitational pull as Jupiter itself. Thus, planetary orbits, the immediate orbits of planets, including Earth, would remain largely unchanged. They would continue their paths as if Jupiter were still present. The asteroid belt. The distribution and behavior of the asteroid belt between Mars and Jupiter would remain consistent, at least initially. Black holes are notorious for their tidal forces, which can spaghettify objects that come too close. However, these effects are pronounced near the event horizon. Given that our hypothetical black hole has the same mass as Jupiter, its event horizon would be minuscule, making such tidal effects negligible at planetary distances. Moreover, for a black hole to have a luminous accretion disk, it needs to actively pull in substantial matter. In this scenario, the formation of an accretion disk is unlikely, as the black hole isn't actively feeding on surrounding material. Radiation emission would be minimal since there's no significant accretion of matter. While the immediate gravitational landscape remains stable, the absence of Jupiter's physical presence could have subtle, long-term effects. Jupiter has been a shield, deflecting potential Earth-impacting objects. Without its massive presence, Earth might experience an increased frequency of asteroid or comet encounters over millennia. Orbital resonances. Jupiter plays a role in maintaining certain orbital resonances in the solar system. Its absence could lead to gradual shifts in these patterns, potentially affecting the stability of some orbits. From our vantage point on Earth, night sky appearance Jupiter, a prominent object in our night sky, would be missing. However, the black hole replacing it would be virtually invisible, making it undetectable without advanced instruments. Gravitational effects. Day-to-day life would remain unchanged. The black hole's gravitational influence on Earth would mirror that of Jupiter's. The sudden replacement of Jupiter with a black hole of identical mass presents a scenario where, surprisingly, the solar system's structure remains largely intact in the short term. The primary reasons include: the gravitational pull remains consistent due to equal masses. Lack of significant matter accretion means no intense radiation or accretion disk formation. However, the protective gravitational influence of Jupiter would be missed over extended periods, potentially exposing Earth to more frequent cosmic threats. This thought experiment underscores the intricate balance and interdependencies within our solar system. It also highlights the pivotal role Jupiter plays in safeguarding Earth and maintaining celestial harmony. For more cosmic explorations and thought-provoking scenarios, subscribe to Knowledge Hub and journey with us through the wonders of the universe.